Okay, greetings to all. This is Dr. M. Shakti Mohan, Associate Professor. Today we are going to discuss about the simplification of Boolean functions using Boolean algebra. Majorly we are going to discuss about the Boolean laws, theorems, postulates, and several formulas related to the Boolean algebra. So we'll see one by one. After discussing those laws and theorems, we'll simplify one problem also by using Boolean algebra. We'll see one by one. Okay. So before entering to the problem, first we have to discuss about the rules of Boolean algebra. So here I'm just listed out some of the basic rules of Boolean algebra. That is, and one major thing, whatever wherever I am mentioning a means it is a variable. Okay, so it is not only a to z, whatever the term, if it is mentioned means that is called as a variable, right? Okay, so please remember that. Okay, so the rule, the first rule is the addition rule. So you can see, so up to this, these are the called as a addition rule. That is a 0 plus a or a plus 0 is equal to a, right? And 1 plus a is equal to 1 or a plus 1 is equal to 1, and a plus a, also a plus a plus a plus how many number of a is equal to a, right? And a plus a bar is equal to 1. So those are the addition rules. So next we are going to discuss about the multiplication rule. Okay, so these are the multiplication rule. That is 0 dot, so dot means multiplication, that is and, right? Okay, so 0 dot a is equal to 0 or a dot is equal to 0, 0. So 1 dot a is equal to a, and a dot 1 is equal to a, and a dot a is equal to a, and a dot a bar is equal to 0, right? So these are the addition and multiplication rules which is available in the sorry, which is available in the Boolean algebra. So the next thing is logical OR operator. So OR means logical addition, that is y is equal to a plus b. So logical OR operator in the Boolean algebra. So these are the logical OR operator in the Boolean algebra. That is 0 plus 0 is equal to 0, 1 plus 0 is equal to 1, and 0 plus 1 is equal to 1, 1 plus 1 is equal to 1. And operator, that is y is equal to a into b, that is multiply b. So 0 dot 0 is equal to 0, 1 dot 0 is equal to 0, and 0 dot 1 is equal to 0, and 1 dot 1 is equal to 1. So next thing is not operator, that is inversion operation. So actually what is inversion means, if the input is a na, the output is a bar. That is what inversion, right? Okay, so here the not operator is 0 bar is equal to 1 and 1 bar is equal to 0. In case 0 double bar means 0. So how means, so 0 bar is equal to 1 and 1 bar means 0, right? So 0 double bar is equal to 0, right? That is the case. And a double bar is equal to a, right? So don't forget. And next we are going to discuss about the laws in the Boolean algebra. Majorly there are three different laws are there. That is cumulative law, associative law, and distributive law, right? So the first one is cumulative law means what now? So a plus b is equal to b plus a, and a into b is equal to b into a. So this is what cumulative law. And the next one is associative law. So what it states means a plus b plus c is equal to a plus b plus c. That is what the first law in the associative law. And the second one is a into b into c is equal to a into b into c. So this is the second law, right? Okay, so the next actually the last laws in the Boolean algebra is distributive law. So it states that a into b plus c is equal to a into b plus a into c. Okay, so these are the laws which were available in the Boolean algebra. Next we are going to discuss about the theorems in the Boolean algebra. So majorly there are two important theorems were available in the Boolean algebra. First one is De Morgan's theorem, another one is principle of duality theorem. So it is very important also. So De Morgan theorem, De Morgan only there are two statements in the De Morgan theorem. It is very easy. A into b the whole bar is equal to a bar plus b bar. this is the first De Morgan theorem. And the second De Morgan theorem is a plus b the whole bar is equal to a bar into b bar. This is the second De Morgan theorem. Actually, it is very easy to remember. If the bar is there in the combined multiplication means while in the addition it will be separated. So likewise, if the bar is combinedly there in the addition operation means it will be separated in the multiplication operation. So sorry for the disturbance. Okay, next. So this is what the De Morgan theorem states, that is AB the whole bar is equal to A bar plus B bar, and A plus B the whole bar is equal to A bar into B bar, right? So this is what the proof for the De Morgan theorem, that is, in case we'll take one input, so A as a 0 and B as a 1. Okay, so now we can check it. So actually AB the whole bar is equal to what? Very simple. 0 into 1 is equal to 0, bar is equal to 1. So that means A into B the whole bar is equal to 1. So now A plus B, so A bar plus B is equal to what? Very simple. A bar is equal to 1 and B bar is equal to 0. So 1 plus 0 is equal to 1. So both are same. So that means the De Morgan theorem is proved. Okay. So likewise, with the help of this table, it will be proved, right? So the first theorem is AB the whole bar is equal to A bar plus B bar, and the second theorem is A plus B the whole bar is equal to A bar into B bar, right? Okay. And principle of duality theorem, it is very simple. Here I'm just to write. So principle of duality theorem means very simple. A plus A bar is equal to 1 and A dot A bar is equal to 0. This is what principle of duality theorem. That is, if you change the R sign into and sign, or the and sign into R sign means the output will be changed. That is what duality theorem. So the example is, you can see A plus A bar is equal to 1. Okay, if you change this R sign into and sign means, that is A dot A bar means the output 1 will be changed to 0. That is what principle of duality theorem, right? So changing of R sign into and sign and and sign into R sign now, so the output will be changed, right? So that is what the De Morgan, principle of duality theorem. Okay, now we are going to discuss some basic problems. So some short kind of problems. Okay, so simplification of Boolean function using Boolean algebra, right? So as of now, we have discussed about the rules, laws, theorems of Boolean algebra. So with the help of these things, we are going to simplify the problem. Okay, simplify the Boolean function, right? Okay, so now we can see the first problem, A plus A into B. Okay, so in that case, so first step is from both the term, I am going to take A as a common term. Okay, if I take A as a common term, now what will be remaining? So from here 1 will be there, and from here B will be there, right? So now what is the rule? 1 plus A or 1 plus B is equal to 1 now. So that means A into 1 is equal to A. Now you can see this is what my input and this is what my output. So simplification is done with the help of Boolean algebra rules, right? So this is how you have to make the simplification. So now we will see the next problem, A plus A bar into B, right? Okay, now it is also very simple. So here for this A, I'm going to put A plus AB because we know A plus AB is equal to A, right? So for this A, I'm just to mention A plus AB plus the second term A bar B. Okay, now you can see from this two term, I'm going to take the B term as a common term. So B term as a common term now, so the remaining will be A plus A bar. So A plus A bar is equal to 1. So B into 1 is equal to B. So the final answer will be A plus B. So the second problem also solved, right? Okay. So next, the third one, A plus B into A plus C. So according to the distributive law, we are going to first to make the multiplication. Okay, so A plus B into A plus C now. So if I multiply it now, so this answer will come, right? So that is A into A plus A into C plus A into B plus B into C. Right? A into A is equal to single A, right? So here I'm just mentioning, and AC plus AB plus BC, right? And from these three terms, I'm going to take A as a common term. If I take A as a common term now, so the remaining will be 1 plus c plus b. So we have already know 1 plus a plus a plus a, how many a it will be, right? So the answer is 1. So that means this will be 1. So the final answer will be a plus b into c. So this is how we have to we just solve the Boolean expression with the help of Boolean algebra. I hope you can understand the today's content. Actually, in this video, we have discussed about the Boolean algebra rules, laws, theorems, and we have discussed about the simplification of Boolean function using Boolean algebra. Thank you.